Good day, everyone. I'm Lai Wenyao, and now I would like to talk about partial fractions. And here are the content. It includes introduction, history, application, requirements, common forms, and conclusion. So now, let's start with the introduction. Partial fractions or partial fractions decomposition are the fractions that used for the decomposition of a rational expression. It is a hands-on method, and it also known as the reverse of the addition of rational expression. Before we look further into partial fractions, I would like to first talk about the history of partial fractions. This is Sir John Bernoulli. He was the one who introduced the technique of partial fraction. He was a Swiss mathematician and also a professor at the University of Basel. He taught many outstanding students, for example, Leonhard Euler. And besides his contribution in partial fraction, he also contributed in some of the topics like theory of differential equation, mathematics of ship sails, and optics. Now, let's look at the application of partial fraction. For example, this is the question given to us for us to solve. First, we can factorize the denominator of it into x minus 3 times 2x plus 1. And hence, we continue from this form. We can write it into a over x minus 3 plus b over 2x plus 1, where a and b are two unknown constants. So after that, we times both sides of the equation with the denominator of the left-hand side, and we obtain this form. So as you can see, we have two unknowns, a and b here. So we need two equations to solve both of these unknowns. And for that case, we need to choose a very nice number of x values so that we can cancel out one of the unknown and solve for the leftover unknown. And here we can let x to be 3 or x to be negative 1 over 2. First, let x to be 3. We need to substitute 3 into both sides of the equation and simplify it. And last but not least, we will get a equal to 2. And when x equal to negative 1 over 2, again, we substitute in the value to both sides of the equation. But in this case, we does not need to sub in the value of a into this equation. It is because, as you can see here, 2 times negative 1 over 2 plus 1 will equal to 0. So in this case, a will be cancelled out no matter how. So we can straight solve for our b. So after some simplification, we will get b equal to negative 1. Now, we already get that a equal to 2 and b equal to negative 1. Now we can substitute the value of a and b into the final form of the rational expression. This is the final form of rational expression that we get earlier. And now we sub in the value into the form. And we just need to simply make it nicer into this 2 over x minus 3 minus 1 over 2x plus 1 will be the final form, the final answer of this question. Now, requirement. There are some requirements that we need to fulfill before we apply the method partial fractions. First, the largest degree of the numerator must be smaller than the largest degree of the denominator. And the largest degree of numerator also cannot be the same as the largest degree of the denominator as well. So in other words, partial fractions can only be applied to those proper fractions. If it is improper fractions, we can apply partial fractions as well. But before applying partial fractions, we must first apply long division. Common forms of partial fractions. So as you can see here, these are the three common forms of partial fractions that we can see, where nx is a polynomial with respect to x, and all capital A, capital B, capital C, and small a, b, and c are constant. We will look at it one by one. This is the first common form of the partial fractions. And here, as you can see, is the example that we discussed earlier. This is being categorized into the first common form of the partial fractions. This is the second common form of partial fractions. And now I would like to look at one of the examples more closer. For example, this. We can write it into the form of the right-hand side. And again, we times the denominator of the left-hand side to the both sides of the equation, and we will obtain this. So as you can see here, there are three unknowns, capital A, capital B, and capital C here. So in order to solve each of them out, we need at least three equations. So in this case, again, we will choose a very nice x value for the equation. So as you can see here, we can choose x equal 1, x equal -2. But there's no other nice value of x we can choose as we observe from here. So does not worry in that case. We can just let x to be any value to make it as one of the equation of to solve the unknown. So in this case, I will let x to be 0. So let's continue from here. When x equal to 1, we will get the form like this. We just need to substitute into the equation, and we will get b, the first unknown that we obtain the value is 4/3. And after that, let's continue with the other two unknowns. Where x equal to -2, again substitute in the value into the equation, and we will get 9c equal -5 and c equal -5/9. Last but not least, when x equal to 0, again substitute the value into the equation, and now we will get -2a plus 2b plus c equal to 1. But we does not worry much about this. It's because we already get the value of b and c just now. So for this case, we just need to substitute in the value of b and c into here, and we can find a. And lastly, we get a equal to 5/9. And now we already get the value of a, the value of b, and the value of c. So we can put into the final form of the partial fractions and obtain the final answer. This is the final form of the partial fractions that we obtained just now. So we just need to sub in the value and make it nicer. And this will be the final answer of the question 3x plus 1 over x minus 1 squared times x plus 2. Last but not least, the third common form of partial fractions. And here are the examples. Again, I will look at one of it. For example, this, we can express it into a over x plus bx plus c over x squared plus 4. Again, times the denominator of left-hand side to both sides of the equation, and we will get this form. But now, in this case, we expand the right-hand side into this. Instead of letting x to be a value and find the unknowns, now we can try an alternative way to find the values of all of the unknowns, which is the method called comparison. So as you can see here, we can compare left-hand side and right-hand side and obtain some of the equation and solve for the unknown. From here, we obtain a plus b equal to c equal -1 and 4a equal to 4. And after solving the above system, we got a equal to 1, b equal to 1, and c equal -1. And after that, we can again complete the equation. And this is the final form that we expressed just now. And now we just need to sub in the value into their respective places, and boom, this will be our final answer of the question. Conclusion. Partial fractions is a very good method that was being discovered is because it saves much time for people when we are being asked to solve some of the final single fraction into their original two or more rational expression, and it also makes our life easier. Here are the references that are being used in this assignment. And that's all of my presentation, and thank you for listening.